Section 3.3, more graphing of lines. So in this section, what we're going to do is we're going to talk about some more details with graphing of lines. We'll look at some special cases as well. So first, let's discuss the concept of intercepts. Intercepts are the points at which a line crosses the axis, or the axes, I should say, the plural. So for example, the x-intercept of a line is the point at which the line crosses the x-axis. The y-intercept of a line is the point at which the line crosses the y-axis. So let's look at this line and determine the x-intercept and y-intercept of the line. Alright, so first the x-intercept. Well, here's the x-axis. Remember, the x-axis is your horizontal axis. So the point at which the line crosses the x-axis is right here. And assuming a scale of 1, right, assuming each mark means 1 unit, the x-intercept of this line would be the ordered pair -4, 0. The y-intercept. Well, remember the y-axis runs vertically, and so the y-intercept is this point. And again, assuming a scale of 1, we have 1, 2, 3, 4, 5, 6, 7, 8. The y-intercept of the line is the ordered pair 0, 8. So now if we sort of think about it a little bit, the x-intercept, since it hits the x-axis, it's not above the origin or below the origin. The y-coordinate must be 0. And similarly for the y-intercept, the x-coordinate must be 0. And so if we would like to find intercepts from an equation, to determine the x-intercept, we let y equal 0 in the equation and solve for x. And to determine the y-intercept, we let x equal 0 in the equation and solve for y. And so this will then immediately give us 2 points, the x and y-intercepts. So use intercepts to graph the equation 5x minus 2y equals -20. Alright, well, let me first find the x-intercept. Alright, so recall from the previous slide, to find the x-intercept, we let y equal 0. Letting y equal 0, we'd have 5x minus 2 times 0 is -20, which tells us that 5x minus 0 is -20. So then 5x is -20. Dividing by 5, x is -4. So this tells us when y is 0, x is -4, so we'd have the ordered pair -4, 0. Assuming a scale of 1 on each axis, the x-intercept is -4, 0. And there it is plotted. Now, finding the y-intercept. To find a y-intercept, we let x equal 0. Letting x equal 0, we would have 5 times 0 minus 2y equals -20. So you'd have 0 minus 2y is -20. So then -2y would equal -20. Dividing by -2, y is +10. So writing the ordered pair, 0, y, we would have 0, 10. Right? X, y, 0, 10. Plotting that point, there's 2 points on the line, and really that's enough to draw the line. And I'll try and do a better job than that. So there's the line, 5x minus 2y is -20. Why don't you pause and try this one on your own? Alright, so finding the x-intercept. To find the x-intercept, I'll let y equal 0. So I'd have 3x minus 4 times 0 is 12. All right, remember 4 times 0 is 0. 3x minus 0 is simply 3x. And dividing by 3, x is 4. So we would have the ordered pair 4, 0. To find the y-intercept, let x equal 0. So we'd have 3 times 0 minus 4y is 12. 3 times 0 is 0. 0 subtract 4y is negative 4y. So negative 4y equals 12, and dividing by negative 4, y is negative 3. And so we'd have the ordered pair 0, negative 3. And then drawing the line through those points, and labeling it. 3x minus 4y equals 12. Alright, so what if we had a slightly different form of the equation? Y equals 1/2 x minus 3. Well, as before, you can do the same process. Find the intercepts and graph the line from there. So I would like for you to pause and try this one out on your own. Alright, so let me find the x-intercept first. So letting y equal 0, I would have 0 is 1/2 x minus 3. Adding 3 to both sides, I'd have 3 equals 1/2 x. Alright, and then dividing by 1/2, which is the same as multiplying by 2, I have 6 equals x, and so then the x-intercept is 6, 0. Finding the y-intercept, letting x equal 0, y would equal 1/2 of 0 minus 3, so y would equal 0 minus 3, y would equal negative 3. And so we'd have 0, negative 3, and now we can draw the line through the points and label it. Now what if we were asked to graph the equation 2x minus 3y equals 0? Now if we use a similar process and find the let's find the x-intercept first by letting y equal 0, you would have 2x minus 3 times 0 is 0. 3 times 0 is 0. 2x minus 0 is 2x, so you'd have 2x equals 0. And dividing by 2, x equals 0. So what we see is this line passes through the origin. And so it is both the x-intercept and the y-intercept. So we saw this situation in the previous section, and what we would need to do at this point is find some other point on the line. And what I recommended in the previous section was to literally solve the equation for y by subtracting 2x from both sides. So negative 3y is negative 2x, and dividing through by negative 3, negative divided by negative is positive, y equals 2/3 x. And so now it still passes through the origin, but now let x equal some multiple of 3. So how about 6? And again, you could have used any multiple of 3 here. Then y would equal 2/3 of 6. And thinking of that 6 as 6 over 1, we would get y equals 4. And so it also passes through the point 6, 4. Alright, so we now have 2 points on the line, and we can draw the line through the points. What if we were asked to graph the equation y equals 4? Now, this equation, there's no x present, so we don't usually use the same sort of methods that we did for the previous exercises. Instead, what I like to do is I like to think when I see an equation like this, where I only see one variable and I'm asked to graph it, I set up a table. And I immediately place the number in the column for that one variable. So it says y equals 4. I'm going to put 4 in the y column several times. And now for the x column, I can choose any numbers for x. So understand what this equation is saying. It's saying the y value must be 4, but we can choose anything for x. So how about -2, 0, and 5? All right, plotting these points. Let's see, -2, 4, 0, 4, and 5, 4. Those points are all on the same horizontal line. Drawing the line through the points, this is the line y equals 4. On all of those points, the y value is 4. All of the points on the line have a y value of 4. So why don't you try this one on your own? Graph the equation x equals -3. Well, if I use a similar process, I set up my table, the x values must be -3. So I'm going to immediately put several -3s in the x column. Then again, I'm going to choose anything for y. So how about -4, 0, and 2? Again, I'm just choosing several numbers. All right, -3, -4, -3, 0, -3, 2. All of these points are on the same vertical line. This is the line x equals -3. A vertical line. All of the points on that line have the x-coordinate -3. So when we see these special cases, if we see just one variable equaling a number, we get one of these special lines, a horizontal or vertical line. A horizontal line will have y equals a number. A vertical line will have x equals a number. So try a couple. Now would be a good time to pause and graph these equations. All right, x equals 5. X equals 5 is a vertical line with x-intercept of 5. So plotting the point 5, 0 and drawing the vertical line through that point. And I'll go ahead and label it. This is x equals 5. Y equals -2 is a horizontal line with y-intercept 0, -2. Plotting 0, I'm sorry, I plotted that incorrectly. Plotting 0, -2. drawing the horizontal line through the points. Alright, so now let's sort of turn it around a little bit. Write the equation of the vertical line passing through negative 7, 2. Negative 7, 2. The vertical line passing through negative 7, 2. Well, negative 7, 2 is over here, just roughly, right? X and Y. We want the vertical line, so that's the vertical line. So it passes through the point, negative 7, 0. It is the vertical line that passes through negative 7, 0 and negative 7, 2. The x-coordinate is always negative 7. So vertical line, x equals a number. Alright, why don't you try the last one on your own? Write the equation of the horizontal line passing through 5, 3. Alright, again, just kind of getting a rough sketch here. 5, 3 is roughly there, and we want the horizontal line passing through that. So there's the horizontal line passing through 5, 3. Notice it also passes through the point 0, 3. So the y value must be 3. Y equals 3.